Hello everyone. Today I'm thrilled to kick off our discussion on vector space, an elegant mathematical framework that's transforming how we understand and interact with the world. Let's start with the fundamentals that make vector space so powerful. A vector space at its core is a set of vector closed and the two key operations, addition and scalar multiplication. When you add any two vectors in a space, the results stay within the space. Think of all forces combined in physics to determine an object movement. Scalar multiplication, meanwhile, lets you scale vectors without taking them out of space, like resizing graphics in design software. Every vector space also includes zero vector that acts like the number zero in arithmetic, leaving other vector unchanged when added. And every vector has a negative counterpart that cancels it out, similar to opposite magnetic fields, neutralizing each other. This property, paired with commutative and associative addition laws, create a flexible system that mirrors real-world phenomena, from displacement in physics to current flow in circuits. Now let's now let's explore how these concepts come to life in science. Physics 2025 has been a breakthrough year. Vector space based motion tracking for autonomous vehicles is 99.2% accuracy, makes self-driving safer than ever. Force vector optimization powered by AI has cut bridge construction waste by 30%. While quantum vector field modeling has boosted MRI resolution by 25%, a game changer for medical imaging. In chemistry and biology, the impact is equally profound. Vector analysis of protein-ligand interactions has accelerated drug discovery by 40%, and dynamic vector simulation predict catalyze efficiency with 95% precision. For biology, single-cell RNA-seq vector analysis has identified 5 new cancer subtypes and protein uh, protein folding prediction now reach 98% accuracy, critical step towards personalized medicine. Even ecology benefits. Vector simulations focus species extinction risk 4 decades in advance. Astronomy and computer science round out the scientific revolution. Vector-based satellite navigation now achieves centimeter level precision, and vector analysis of James Webb Telescope data has mapped dark matter in over 100 galaxies. In computer science, multilingual vector embeddings support 100 plus language with 97% translation accuracy, while vector clustering detects financial fraud with 99.5% record. These applications aren't just theoretical, they're solving real-world problems right now. To wrap up, vector space are more than math. They are a universal language for describing the natural world. Their simple yet powerful property enable possess efficient modeling across every scientific discipline. Next, my colleague will dive into how these ideas shape engineering. Stay tuned for even more remarkable.
Okay, now let's talk about engineering application of vector space. Thank you for that fantastic foundation. Now let's shift our focus to generating real vector space aren't just tools, but the backbone of cutting-edge innovation. From mechanical systems to aerial technology, vector space are driving efficiency, precision, and breakthrough that were once impossible. Let's start with mechanical and automotive engineering. In 2025, vector path planning allows collaborative robots to work with 0.1 millimeter precision, transforming manufacturing by enabling seamless human-robot collaboration. For civil infrastructure, vector-based structural health monitoring detects bridge defects 6 months early, preventing disasters and saving billions in automotive design. A AI-optimized vector control has boosted electric vehicle range by 20%, a key step towards sustainable transportation. Okay, electrical engineering is another area where vector spaces shine. Power grids now use vector AI models to predict faults with 98% accuracy an hour in advance, minimizing blackouts. For 6G, vector-based signal modulation has increased data rate by 10 times, while vector optimization of renewable energy grids has cut carbon emission by 30%, critical for fighting climate change. In communication, vector OFDM modulation enable 100 Gbps wireless transmission, and a massive MIMO vector beamforming will triple 6G coverage, connecting more people than ever before. Civil and aerospace engineering take vector technology to new heights. Vector simulations of earthquake impacts has reduced skyscrapers damaged by 50%, making cities safer. AI-driven vector analysis predicts late signs with 92% accuracy, protecting vulnerable communities. For aerospace, vector-based trajectory optimization has cut Mars mission time by 15%, bringing interplanetary travel closer. Quantum vector control stabilities geostationary satellites with 0.01 angle precision, and vector analysis of engine airflow has reduced fuel consumption by 25%, a huge win for both cost and sustainable. And now, biomedical engineering occurs between science and engineering leverage vector spaces to save lives. Cardiac digital twin models built on vector space enable personalized algorithm treatment. Tumor microenvironment modeling optimizes immunotherapy and vector space algorithms enhance MRI and CT scan analysis, improving disease detection accuracy. Wearable devices now use vector spaces for real-time biofeedback, helping people monitor and regulate their health dynamically. Quantum technology are pushing these applications even further. Lattice-based cryptography uses vector space for post-quantum, keeping data secure in the quantum era. Quantum machine learning, like Beijing Quantum Academy's QRDR, has boosted OSVM accuracy to 89.37%, while Origin Atom's QCNN processes 100K images per second with 2,055 photons. These innovations aren't just engineering feats, they are reshaping how we live, work, and explore. In summary, vector spaces are the unsung heroes of modern engineering. They turn complex problems into manageable models, enabling precision and efficiency across every field. Next, my college will explore the advantages, challenges, and future of vector space applications, showing us where this journey is heading.
Incredible engineers and applications. Now let's take a step back to examine why vector space are so impactful, the challenges they face, and the exciting futures that lie ahead. First, let's celebrate the core advantage. The core advantage of the vector space's efficiency is a standout. In 2025, vector parallel computing processed 100 TB of the genomic data in just 1 hour task that once took weeks. Precision is another strength. Coordinate vector models predict climate changes impacts with 90% accuracy, helping policymakers make data-driven decisions. Perhaps most importantly, vector spaces over intuition problems representations. AR vectors visualization simplifies complex engineering designs, letting non-experts contribute to innovations democratizes technologies in powerful ways. Of course, no technology is without challenges. The causes of dimensionality has long blocked high-dimensional data, but the 2025 brings solutions. Coordinating vector dimensional reduction handles 1 million plus pictures in real time. Model generalization, applying models across different domains, was once a barrier, but transfer learning with vectors embedded in has improved cross-domain performance by 60%. Computational resource limits are also being addressed. Edge AI vector process reduce energy consumption by 70%, making vector technology accessible even in resource-constrained environmentals. The future of the vector spaces is brighter than ever, with an emerging chance set to redefine what is possible. Quantum computing will deepen integrations, enabling even fast processing and more complex modeling. In healthcare, vector-based digital twins were involved to predict disease progressions for nuclearizations conditions. Over earlier intervention for millions, sustainability vector optimizations will further reduce carbon emissions in energy grids and transportation, accelerating our shift to a green economy. For engineers and scientists, this means endless opportunities. Vector space will continue to bridge the gap between theories and practice, turning abstract math into triangulable solutions, while it is detecting cancer earlier, building safer cities, exploring distance plans. Vector spaces will be at the center of the next wave of innovations. To conclude, vector spaces are more than a mathematical concept. They are a list for programs. Their advantage in efficiencies, precision, and the intuitive make them indispensable, while emerging solutions are overcome historical challenges. As we look ahead, the vector spaces will keep pushing the boundaries of science and in engineering, improving lives and solving the world's most pressing problems. Thank you all for joining. Thank you all for joining us on this journey through the powerful vector spaces. We can't wait to see with you to build them with. We can't wait to see what you will build with them next. Thank you.